everyone, welcome back. So this is the practice solutions to the lesson for this week. All right, so let's get started. So the lesson that we spoke about this week was talking about tangents to a circle. In order to do these problems, we need to understand what tangent is. So a tangent is which, no matter how far extended, intersects a circle exactly one time. Now, we have a diagram here, which is also on your handy helper, that says we have line M is tangent to circle O at point A. So what does that mean, or how do we know that? We have circle O, and then we have this line M here, and once again, a tangent is when it touches a circle exactly one time. So this tangent line M here touches circle O at point A. And point A is also called a point of tangency because it is the point that intersects the circle. Okay, remember, intersect doesn't necessarily mean it has to cross through the circle. As long as it touches it, it is called an intersection. All right? All right, so let's get started. So here's our first problem. It says line CB is tangent to circle A at B. And we want to find the length of CD. So CB, we understand, is tangent because it touches the circle once, okay? And then it says it's also to circle A at B. So for that particular piece, it says when a radius meets a tangent line at the point of tangency, they create right angles, which means they are perpendicular. Now, perpendicular forms right angles, and right angles are 90 degrees. So we could label this piece right here with a 90-degree angle mark, okay? We need to find the length of CD. So this is the piece we have to look for, so I'm just going to label it X for right now, okay? Now, what do you notice about this image? We have a right triangle, okay? Now, when we have a right triangle, there's two different ways we could solve this problem, but we have to know exactly which particular one we must use. In this case, we'll be using a squared plus b squared equal to c squared. Now, what's the other method? SOHCAHTOA. How do we know which ones to use? Right triangles, we know if it's dealing with all three sides, we're going to use the Pythagorean theorem. If we had angles and sides other than the 90-degree angle, then we would use the SOHCAHTOA method. So, all right? So in this case, C represents the hypotenuse, all right? So which part of this right triangle is the hypotenuse? AC, okay? So we know that AC is representing the hypotenuse, therefore the other two sides will be considered legs. So it doesn't matter which order we write those two in, as long as we have the legs on the same side. So we have 8 squared plus b squared, 15 squared. Equal to, I'm going to write AC squared for now. There's a reason why I'm going to do it that way. Okay? So now we could basically solve this problem. So we have 64 plus 225 equal to AC squared. All right? 64 plus 225 is 289. And then to get AC by itself, we have to take the square root of both sides. So AC is equal to 17. Okay? So we know that this whole side here is equal to 17. Now, how can I just figure out what CD is? All right? Now, remember, A is the center of the circle. So any line that goes from the center to the end of the circle is called a radius. And all radii from the same circle will be equal. So AB is a radius, and that is 8 inches. So therefore, AD will also be 8 inches because it is also a radius. So now, moving forward, we can now figure out what CD is. We know the entire length, and we know a part of the length, so we could find out the other part. In order to do that, we're just going to do 17 minus 8 to get CD. And 17 minus 8 is 9. So the length of CD is 9 inches. Okay? All right, next one. So now we have circle O is inscribed in triangle ABC with D, E, and F as point of tangencies as shown. AE is 15, EC is 10, and BF is 14, and we want to find the perimeter of triangle ABC. Okay, so let's just fill in a few things. We know that AC is 15. We know that EC is 10. And we know that BF is 14. Okay? The word perimeter means we want to find the sum of the exterior. So we want to find the perimeter of triangle ABC. So ABC is this triangle on the outside. So we want to find the length of all 3 sides and then add them up. Okay? So how can we go about doing this problem? As noted on our handy helper, if 2 tangent lines meet at the same external point, the tangent lines are congruent. Okay? So what does that mean? If I look at AE, we know that AE is tangent to circle O because it touches once, exactly one time, and is considered the point of tangency. So the external for E is A or C. So it depends on which way we're going. So if I'm looking at A, the 2 tangent lines that meet A will be equivalent. So if you notice, I also have another point of tangency here at D. And just to make sure we understand, F is also a point of tangency. So if I'm looking at external point A, 15 AE and AD will be congruent. If I'm looking at external point B, BD and BF will be congruent. If I'm looking at external point C, EC and FC will be congruent. So now it's basically just a fill-in. We know that these are congruent, so if this is 15, then this must be 15. If this is 14, then this must be 14. And then if this is 10, this side here must be 10. Okay? And once again, perimeter means we want to add up all the sides. All right? So we have 15 plus 15 plus 10 plus 10 plus 14 plus 14. When we use our handy dandy calculator, we get 78. So the perimeter of triangle ABC would be 78. Easy? I hope so. All right, last one. So this one says, in the figure shown below, we have quadrilateral TAEO is circumscribed around circle D. The midpoint of PA is R and HO is congruent to PE. If AP is 10 and EO is 12, what is the perimeter of the quadrilateral TAEO? So there's a few things here, all right? It says the midpoint of TA is R. So what does that mean to us right now? TR is going to be congruent to AR because midpoint means basically to split something into 2 equal parts, okay? Then it also says HO is congruent to PE. So I'm just going to mark this as HO is congruent to PE. Okay? Then it says AP is 10. And we have EO is 12. And then we want to find the perimeter for the quadrilateral TAEO. So this looks a little different, but it's very similar to what we just did. So keep in mind again, if two tangent lines meet at the same external point, the tangent lines are congruent. So if you notice, R, H, Z, and P are all points of tangency. They all touch the circle one time. Okay? So let's go through it. So if I'm looking at external point A, we know that AR should be congruent to AP. So these two pieces are going to have the same markings. If I look at external point T, TR will be congruent to TH. So we have the same markings. If I have external point O, then we know that HO will be congruent to ZO. And then if I'm looking at external point E, we know that EP should be congruent to EZ. Okay? So now let's just fill in a few things. We know this is 10, so this must be 10 here, this must be 10 here, and this must be 10 here, because they all have the same marking. Okay, now let's look down at the bottom. They gave us this whole thing to be 12, but we have all these markings here that are equal. So what do you think we can do? If you work backwards, think about what happened up here. This was 10 and this was 10 because they had the same marking. If I were to look at the entire length of AT, that entire length would have a sum of 20. If I look at OE, we have a sum of 12. And if OZ and EZ are equal, we could basically divide 12 into 2 equal parts. So this would be 6, and this would be 6. Therefore, HO would be 6, and PE would be 6, because they all have the same markings of the double tick. Okay? Now, once again, perimeter just means we want to add up all the sides of the quadrilateral TAEO. So we have 10 plus 10 plus 10 plus 10, and then we have plus 6 plus 6 plus 6 and plus 6. Okay? And this sum would be 64. Okay? So, one more thing. The reminders, men, all right? So on Tuesdays, just remember these, all right? On Tuesdays, we watch the videos and we take notes and we want to attempt at the practice problems. On Thursdays, you want to watch this video and edit your problems before submitting. Okay, remember, when you're submitting your work, you must have the correct answers to the practice problems because we're giving them to you. All right, you must complete the exit slip. Make sure you are 100% sure about your answers there before clicking submit as well. And last but not least, work on the homework. All of these are due Sunday by 11:59 p.m. So please use the pacing calendar to help you work your way through the week, but make sure everything is done correctly and complete and submitted by Sunday, 11:59 p.m. Okay? Don't forget your password also. All right, take care. Bye-bye.